Primary schools, the design of educational buildings in the tropical climate. The project is located in Guatemala, a country with 8 climatic regions, where 45% of rural children are working children, 41% of these children are enrolled in school, with a rate of school abandonment of 65%. This is due to the lack of funds, resource distribution, school abandonment, construction quality, school comfort, academic performance, and accessibility to educational centers. The area that was studied for this project is located in Guatemala's main seaport, located in the tropical rainforest region, with annual temperatures between 27 to 32 degrees. Colonia Nueva Esperanza is a site where 250 students receive classes in outdoor areas, carrying their desks in search for shelter under nearby trees or buildings to be able to study. The design agenda is to create a self-built prototype to increase indoor and outdoor comfort, to improve academic performance, promote use of renewable resources to achieve a positive energy performance and reduce school CO2 emissions, save time and cost through standardized and adaptable design prototypes, reuse and recycle materials such as water waste to promote sustainable communities, generate a learning space planned and built to promote sustainable living, and moving from a traditional linear system to a circular system to create a free-running net zero and passive design prototype. The climate of this region is separated between the wet and the dry season, where we can say high levels of humidity and high levels of precipitation throughout the year, and vertical sun angles. The school year runs from January to October, with a summer break between June and July, and an Easter break in April, with occupancy hours between 7 to 3:30 p.m. During the wet and the dry seasons, temperature oscillates between 19 to 34 degrees Celsius. To carry the analytical work, typical schools in the area were studied to determine a base case, where the U-shape and linear typologies were the most common, with 30 students per classroom. Materials used in these designs is concrete blocks, single glazing, metallic doors, steel structure, and corrugated steel. Thermal analysis showed that these typologies tend to overheat both in the dry and the wet seasons, reaching temperatures up to 39 degrees during the school schedule. To improve this, the prototype will base its studies on roof typologies, ventilation, envelopes, and daylight analysis. To optimize the roof structure, thermal analysis were run in a single, double roof, elevated roof, and double elevated roof to determine what roof topology is the most adequate for this climate. Thermal analysis were also run to determine the window-to-floor ratio, ventilation, equipment, lighting, and envelopes were necessary to keep temperatures in the comfort band. The best solution for this climate area is the elevated double roof with cross ventilation and a window-to-floor ratio of 25%. The design proposal is based on the hexagon or honeycomb shape. The hexagon form is structurally more stable. It can be easily arranged in desired patterns to be able to have more flexibility to different sites and configurations, to create microclimates between classrooms, reduce area of construction, to reduce costs. A thermal analysis was carried comparing the rectangular class versus the hexagonal class to make sure that this shape would not compromise the thermal performance. The hexagonal class with a double elevated roof keeps the temperatures within comfort throughout the wet season and the dry season. Using an hexagonal shape also reduces the construction area by 30 square meters, which will reduce the costless construction. The envelope was based on a bamboo roof layer with a twill roof layer underneath, with 360 rotating pivot walls, bamboo floors, and bamboo vegetated walls. The structure is a prefabricated off-site steel frame structure and concrete foundation with elevated floors over steel structure fitted on site. The wall composition can be installed in any of the structure's frames, giving the flexibility to configure classes as desired and to choose the possibility to connect or isolate class modules. The use of these materials helps the prototype to keep within comfort during the dry and the wet seasons, with temperatures oscillating between 24 and 29 during the hottest weeks of the dry season and the wet season. A UDI analysis was also carried to understand the daylight behavior with an 89% of daylight hours throughout the school year. It also showed that there is no glare until 3 p.m., which can be resolved by closing the pivoting walls. Solar water heaters, solar panels, eco filters to collect rainwater to transform it into drinking water, rainwater harvesting, rainwater collection, and compost systems will also provide a net zero and waste-free prototype. This prototype can not only reduce indoor temperatures on typical public schools, but it can also be a use of natural resources and materials in the local area to provide a safe environment for kids to study with an affordable solution with a sustainable agenda.